Welcome to our revision session for IGCSE Math 0580 Extended. Today we'll be doing Unit 1 Numbers. First, we need to know the type of numbers. There are 5 types of numbers we'll be dealing with in this course. The first is an integer. Integers are whole numbers. Examples would be both negative and positive, like -3, -2. 0 is also an integer. And moving on to the positive numbers like 1, 10, 106, etc. Prime numbers. Prime numbers are numbers that can only be divided by itself and 1. Example of a prime number would be 23 because it is only divisible by itself and 1. And 24 is not a prime number because it can be divided by 6 and 4. Now, natural numbers. Natural numbers are positive integers, which is positive whole numbers. So any integer that is greater than 0 is a natural number. 1, 2, 3, 4, Now, cube numbers. Cube numbers are numbers that are cube of another number, another integer to be precise. Example would be 64. It is 4 cube, or 8. It is 2 cube. The square numbers. Square numbers similar to cube numbers, which is square of another number. Example would be also 64, which is the square of 8. And 16, which is square of 4. Now move on to common factor. Common factor between two numbers is a number that can divide them both. Common factor between 24 and 32 would be 8, because 24 is 3 times 8 and 32 is 4 times 8. In the exam, you will see something like the greatest common multiple, which is asking for the greatest common factor, and in this case would be 8. Common multiple. Common multiple between two numbers is a number that is divisible by both of two numbers. A common multiple of 24 and 32 is 96, because 96 is 4 times 24, 3 times 32. A way to find the least common multiple is first break down the two numbers into their prime factors. For 24, it would be 2 times 2 times 2 times 3. But break it into all primes. 2 is a prime because it is only divisible by 2 and 1. 3 is a prime because it is only divisible by 3 and 1. Same with 32. It is 2 times 2 times 2 times 2 times 2. And to calculate the least common multiple, you times the greatest common factor, 8, and the rest of the factors. So this will be 8 times 2 times 2 times 3, which is 8 times 4 times 3, which is 96. Now moving on to sets and set notations. Here's an example. A is the number of students who take physics. B is the number of students who take chemistry. Let's say there are a total number of 120 students, and there are 20 of them who took neither. So which leaves us 100 students who took chemistry or physics or both. And I say there are 50 of them who takes physics and 70 of them who takes chemistry. The sum of A and B when we're looking at it, is over 100 because there are actually students who takes both. Let's say 30 students who takes only physics, which leaves us 20 of them takes both, and thus 50 of them who takes only chemistry. And Na here, which means the number of elements in A. This example would be 50, because there are a total of 50 students. This symbol is belongs to. We can say that student 1, let's say student A instead. So if student A is inside students who take physics, we can say that student A belongs to set A, and student A doesn't belong to set B. This sign here is for empty set. So if a set has no elements, we can say that X is an empty set. This sign is universal set, means all the elements in this big universal set. And here, this is A is a subset of B. So we can say that A and B here is a subset. So number of students who take physics and number of students who take chemistry is a subset of number of students who take science, has science of one of their subjects. Here, similar to belongs to, this is not a subset of. So a student who only takes history is not a subset of students who take science. Here is A union B, which means A or B. In this case, if we say the number of A union B would be this whole part, which is 100. And here is A and B, which is the intersection part of A and B. If we said number of A and B would be the middle part here, which is 20. Power and roots. So first, let's do power. We write power on the top right corner. In any numbers, any real numbers, so integers, decimals, fractions is all okay. 5 to the power of 2 would be 5 times 5. 5 to the power of 3 would be 5 times 5 times 5. And 5 to the power of 1 over 2 would be square root 5. And if we have 5 to the power of 1 over 3, it would be cube root 5. So if we have 5 to the power of 2 over 3, we'll have 5 squared, then cube root, or the other way, cube root 5, and then squared. Now, if we have negative numbers, 5 to the negative 1, which means 1 over 5. If we have 5 to the negative 2, we'll have 1 over 5 squared. When we are multiplying numbers with power, like 5 to the power of 3 times 5 to the power of 2, we add on the power, which is 5 to the power of 3 plus 2. And when we divide, we subtract the power. If we have 5 to the power of 3 divides by 5 to the power of 2, we'll have 5 to the power of 3 minus 2, which is 5 to the power of 1. This is pretty easy to understand because 5 to the power of 3 is 5 times 5 times 5. If we times another 5 times 5, it will be a total number of 5 times 5 times 5 times 5 times 5, which is 5 to the power of 5. And in the opposite way with divisions. Now, when we're multiplying numbers with the same power but different base, 3 to the power of 5 times 2 to the power of 5, we multiply the base, which is 6 to the power of 5. And if we have, it works the same for roots. If we time square root 5, which is 5 to the power of half, and 5 to the power of 3, we'll have 5 to the power of half plus 3, which is 5 to the power of 7 over 2, which is also square root 5 to the power of 7. Fractions, decimals, and percentages. So first we'll do fractions. A proper fraction is a fraction with its numerator smaller than the denominator. An example would be 3 by 4, 8 by 24, or also 1 by 25. An improper fraction is a fraction with its numerator greater or equal to its denominator. Examples would be 24 over 24, 25 over 24, something big like 1,000 over 2. For mixed numbers, when we have an improper fraction, we can turn it into a mixed number. If we have 25 over 24, we can turn it into 24 over 24 plus 1 over 24, which is 1 and 1 over 24. And we do the same when we turn a mixed number into an improper fraction. We have 3 and 2 over 4. We first times 3 by 4. So we'll get 12 over 4 plus 2 over 4, thus 14 over 4. And moving on to decimals. We can turn decimals into fractions and fractions into decimals. For example, 3 over 4 would be 0.75, and 0.5 would be 1 over 2. And if we have recurring decimals like 0.121212, recurring the 1, 2, how we'll turn it into a fraction is refer to the sign, let's say t equals 0.12121212, and 10t, 100t in this case, would be 12.121212. Then we'll do 100t minus t equals 99t. And this cancels out the recurring 0.121212, leaving out 12. So t would be 12 over 99. Now percentages. When we see a percentages like 15%, 50%, 83%, it is actually base 100. So this is 0.15, 0.50, and 0.83. When we want the percentage of a number, we can divide it by the number. So let's say we want to know what percentage of 80 is 15. We'll divide 15 by 80. And the answer would be 0.1875, which is 18.75%. Limits of accuracies. When we're doing physical measurements, there will be a uncertainty. For example, when you're using a ruler to measure a pencil, the ruler is only precise for down to 0.1 centimeter. So your uncertainty will be half of the minimum measurement, which is 0.05 centimeter. This is plus or minus. This is the uncertainty for your measurement. And upper bound and lower bounds will be used in estimations. We can say a wall is 2 meters high, measured 2 meters. So measure 2 meters means it is round 2 meters. So actually 2 meters, let's do a number line. Here is 3 meters and here is 1 meter. So to what range would the number be estimated to 2 meters? It would be the lower bound would be 1.5 and the upper bound would be 2.5 because any number greater or equal to 1.5 would be estimated to 2 and any number that's smaller than 2.5 would be estimated to 2. An example of question. So the wall is measured to 2 meters high to its meters and 4.4 meters wide to 1 decimal point. Find the maximum area of the wall. For 2, we already know the upper bound is 2.5 meters. And for 4.4 meters, we see here it is measured to 1 decimal point, so 4. And we plus minus 0.05 because any number that's greater or equal to 4.35 is estimated to 4.4. So the lower bound for 4.4 is 4.35 and the upper bound is 4.45. So in this case, we want the maximum area, so we'll use the upper bounds, which is 2.5 times 4.45. Now we're moving on to ratio and proportion and percentages. An example would be 20 to 60 to 40. And if we simplify it, we could first divide by 10. Makes it to 2 to 6 to 4. And then we divide by 2, which is 1 to 3 to 2. So in a question, you could see something like 60 sweets are split among 3 children. And the ratio 20 to 60 to 40. How many sweets does each child get? So we total will have 6 units and 60 candies. So 1 unit equals 10 candy. Thus, children will get 10, 30, and 20, total of 60 candies. Proportion is something similar. Let's say still 60 candies. So what proportion of candy did the second child get. The second child had 30 candy, so 30 out of 60, which is half. Pretty easy. And in percentages, still this example, half percentage is 0.5, which is 50%. Rates. Rates is similar to ratio. For example, a car is at a speed of 20 meters per second. Remember, second to the power of -1 is meter times 1 over second. So the rate of its increase in travel distance against time is 20 meter per second. This is rate of the increase of the distance traveled by the car. Another rate would be money exchange. For example, $1 can exchange 7 Chinese yuans. The rate for the dollar to yuan is 7. But backwards, yuan to dollar is 1 over 7. So if you have $100, you can get 700 yuans. But if you had 700 yuan, you'll only get $100. Now moving on to exponential growth and decay. The definition for exponential growth or decay is that the rate of change, which is proportional to its current value. Example of an exponential growth would be complex. Let's say I invest $500 for 10 years, and the annual interest rate is 5%. What will I get after 10 years? So after the first year, 525, because it is increased by 5%, so times 1.05. And by the second year, I'll have 525 times 1.05, which is 551.25. And the third year, it will be 551.25 times 1.05, which is 578.8125. You can see the pattern here. So the equation will be the final output equals the initial investment times the rate, 1 plus rate over 100 to the power of year. In this case, my final output would be 500 times 1.05 to the power of 10, which is 814.45. An exponential decay is something similar. If a car drops its value by 5% every year, what will be its value after 10 years? So it would be the inverse. Instead of 1.05, it would be 1 minus the rate. So it's actually 0.95. Again, using 500 as an example, it will be 500 times 0.95 to the power of 2. Now, the last topic, surds. A surd form for numbers would be a real number, an integer, or fractions, and a root. A square root, a cube root is fine. So if we put square root 20 in surds form, it will be square root 4 times 5, which is 2 times square root 5. And if we do multiplication with surds, like 3 over 2 times 4 over square root 5, well, first multiply the number outside the square root, which is 12, and then we multiply the number, and that's it for Unit 1.